Hi everyone, this is Valerio from the R3 product management team, and I'm here with Nick from our engineering kernel team,
Hiya.
and we're here to talk about a performance improvement we have added to Corda Enterprise 4.4, bulk backchain fetching.
Right, so what we've done in 4.4 is introduce a mechanism where we can request multiple items of backchain at the same time rather than just one item as is currently in 4.3. So basically what this means is when we know about a number of input transactions, we can actually request all of those transactions from another node in one go, and when those transactions come back, we can find out what they're dependent upon, and we can request all of those transactions in one go. So this means that we can effectively reduce the time to traverse the backchain in order to be able to sign the transaction, which obviously requires the full visibility of all the historic transactions.
So you mentioned traversing the backchain. That's a very Corda specific concept, so we can probably give our viewers an overview of what is the life cycle of a transaction in Corda and where this performance improvement we've introduced actually kicks in.
Yeah, I mean, you're right, it is a Corda specific feature, and it's because the way Corda works is to have a privacy model such that you don't necessarily get to see the backchain until the point that you need it. So what this means is that nodes that don't actually participate in transactions don't have visibility of those transactions or the input states. So what happens is when a node makes a transaction that's dependent upon something it hasn't seen, then it has to request the information from another node, the one that's it's interacting with, and that node then needs to supply the historic chain leading up to this transaction. So as a for instance, if I was to give you some money, you go, where did I get that? Where did you get that money from? And therefore I'd have to find out the transaction that gave rise to creating that state, i.e. the money, and then tell you that. So at the moment this is done one at a time, and what we're doing now is we're requesting a number of items in one go based on what we have knowledge of, which is dependent upon what comes back.
Okay, that's great. Let's dig a bit deeper into how transaction verification works in Corda at the moment and how we have applied these performance improvements. So just to give a reminder to who's viewing the video about what part of the transaction lifecycle of Corda has become faster with this. So transactions in Corda go through a different phase before they get added to the ledger. So first they're built by a participant, then they're proposed to other participants and signed and made immutable, and then when all the participants that were required as signers have performed the signature, the transaction is notarized, distributed and recorded on the ledgers of each participant. So if I understood correctly, the improvement here happens while the signing phase is happening on each participant of the transaction, but before each participant actually signs. Is that correct?
Correct. You need to have the chain when you actually perform the signing, because in order to sign a transaction you need to know that the inputs are not already spent, and you need to see which transactions created those inputs. So you basically have to request the transactions that gave rise to the input states. So by doing it one at a time, you're effectively going slowly down the list, whereas now we're actually doing this multiple times, which will speed up the signature part of the process.
Okay, so basically to make sure that the transaction you're about to sign is valid, you need to go and verify all of its dependencies.
Correct.
So all of the transactions that originated some of the input states to your transactions, and you have to do this recursively until basically every issuance of the...
Right. You can't just go signing something without making sure that the input states are not spent already.
Mm-hmm. And a participant that is doing this needs to have access to all those dependency transactions, so they need to fetch them from somewhere if they don't have them somewhere in their local storage.
Correct, and this is known as backchain fetching.
And this is something that is done by the node that is proposing the transaction. They're the one that actually potentially have to go and fetch.
Correct, and it's done before they sign the transaction.
Okay. So let's look at how this backchain fetching process happened in Corda, before Corda Enterprise 4.4 actually. So let's say we have been proposed a new transaction, transaction 1, we want to sign, and we want to go through the verification process of the content of the transaction. For doing that, we need to have access to all the dependencies of this transaction. And the way this was done before Corda Enterprise 4.4 is um, every item was fetched depth first and one item at a time. Is that more or less?
Correct. So looking at the diagram that you now have, you can see that transaction 1 is dependent upon transaction 2, 3 and 4. So you would therefore go and request transaction 2. So once you'd done that, that would come back and you would see that it was dependent upon transaction 5. So you'd then fetch transaction 5. You would then proceed to look at your next transaction, which is transaction 3, which then yields 6 and 7 as bin dependent, so you would then fetch them individually. So looking at this diagram, you can see that you're effectively doing a depth first walk left to right of the tree, visiting every node one at a time. So the time it's going to take is going to be proportional to the number of nodes in the backchain, regardless of the actual topology of the network.
And in a worst case scenario, you basically end up doing 7 round trips here.
In this instance, you would be potentially asking for 7. I mean, it may be possible that certain transactions you already know about in memory.
Exactly.
So that in the worst case, it could be 7, yes.
Okay. And so let's have a look at how things have changed in Corda Enterprise 4.4. So starting point is the same. We still have this transaction 1 that we want to verify the validity of. And so what's changed is that now instead of going depth first, we go breadth first, and we can fetch more than one item at the same time.
Correct. So looking at this model you've got here, transaction 1 we already know is dependent upon transactions 2, 3 and 4. So we can make a single request and a single round trip to another node to request transactions 2, 3 and 4 in one go. Now when they come back, they're going to yield 5, 6, 7 and 8 as their dependencies, so we can then actually request all of those 4 in one go. So therefore we've made 2 round trip requests.
When potentially before we might have had to do up
and
to 7.
You can also see that with this diagram that if the chain was to get wider, which is highly probable if it was, for instance, a financial spending type system that was being used here, then the chain, as the chain would get wider, the potential for a performance increase would improve.
Right. And I guess that leads us nicely into some of the current limitation of this. When we were discussing this before, you mentioned this is not a, catch-all performance improvement that works in every situation. Some of our more clued up viewers will have already figured out that in a case like the one we have here, when you have a long linear dependency chain, you still will have to do
correct. I mean, this fix does not actually apply in that situation, so it is very much dependent upon the data. There potentially may be other ways we can look at in the future, but this is one of a suite of things we would hope to be able to roll out over time.
And so I guess it's important for viewers to know that this is an improvement that will likely apply if your application is transacting fungible assets, so like cash tokens or something like that.
Correct. I mean, the nature of cash tokens is that you will receive coins from potentially multiple sources, probably more than 2 or 3 sources that you've shown previously. It's highly likely that that model will exist, and therefore you will be able to ramp up the size of the width of your fetch block as you go down. So therefore I would expect it to be significantly faster in those scenarios.
Makes sense. And I guess there's another thing that people need to be aware of, which is the fact that you can't get an infinitely large batch as part of this. This is still regulated by how large is the maximum message size in your network. Is that correct?
It's regulated by 2 things. It's regulated by the maximum request batch size.
True.
Which means that you can nominally say it's defaulted to 50 at the moment. You can set it. You then cap your width at 50, and that's just to prevent the node at the other end receiving an excessively large width. For instance, if it was thousands, it might not be considered to be a good idea to request so many in one go. It's also the number that get returned is subject to the maximum network message size. So therefore, if the messages themselves are very large, then potentially you may not be able to actually get all of them back in one go.
Hmm.
So in that instance, you may say request 50 and get 40 messages back. It will cope with this scenario because what it will do is it will put those 50 into the head of the next batch that's requested.
Okay.
So it will cope automatically. It will always return at least one item because that's the existing behavior. And if you don't return at least one item, then you're never going to actually complete fetching the batch.
Fantastic. Okay. Talking about, you just mentioned like it will always return at least one item. Let's have a look at how this works with nodes that are not running on Corda Enterprise or are running on previous versions of Corda. So what's the compatibility of this feature with other versions of Corda?
This is an Enterprise 4.4 feature. 4.4 will request multiple items if it's talking to another 4.4 node, and that includes an open source node. An open source node can supply multiple items back to Enterprise, but an open source node will only be able to request one item. So if you're running open source 4.4, both sides, you won't have a benefit, but if you're running Enterprise on the client side, as in the requesting node side, then you will get this benefit whether you're talking to open source or another Enterprise node. If you're talking to anything below that 4.3 on or below, then you will get existing behavior and it will request one item at a time. So it's fully backwardly compatible based on platform version.
Great. And actually, this node configuration property we have introduced allows people who are running nodes on Corda Enterprise 4.4, I think, to actually roll back cleanly to the old behavior.
Correct. The backchain fetch batch size in config, it's defaulted to 50, so you don't need to put it in if you want to take advantage of this automatically. You can theoretically set it higher. This was just a nominal value for the first release. You can also set it to 1, in which case it will request one item at a time as before, but it will actually also use the same code as before. So the request type will be the old request type, which will make it fully backwardly compatible and effectively roll back this change without having to actually roll back 4.4 in its entirety.
Got it. All right, I think we covered this feature pretty well. Thank you very much, Nick, for explaining everything to us.
No problem.